previous video, we looked at entering farm setup cost data. In this video, we look at setting up the operating costs, which are the routine costs which occur with each production cycle and within each year. In general, operating costs fall within two categories: variable costs, which vary in proportion to the quantity of production, such as feed and fry, and fixed costs, which are not directly linked with the quantity of production, such as administration costs. The Operating Costs button on the Start Here sheet take you to a sheet where you can enter more details about your operating costs, so that you can see a more informative analysis of the strategy options that you select. These costs are in addition to the feed and fry costs which we set up in a previous video. The first table lists several costs that you may wish to take into account. The table provides suggested default values for each parameter, or you can enter your data. As with the first table in the Setup Costs sheet, you opt to either use the default values or your directly inputted values using the drop-down selector above the table. Unlike the Setup Cost sheet, only one of the default values here is calculated from other workbook data. This is the suggested number of labourers, which is calculated according to the average daily feed amount. The more feed that has to be transported to the cages and fed to the fish, the more labourers are required. You can adjust this ratio in the Labour to Feed table, which can be reached by clicking on the Labour and Fuel table button. Note this also affects the default value for the number of labourers in the farm setup costs. This is the lookup table, so firstly you can edit the average daily feed quantity column to suit the range that might be used on your farm. However, ensure the values are in ascending order. The numbers of labourers required to distribute each feed quantity can then be entered in the second column. This table is also used in the calculation of fuel costs by assuming there is a positive relationship between the amount of feed fed and the number of boat engine hours required. Adjust these figures to match what happens on your farm. Consideration should also be given as to whether the number of labourers employed needs to be higher than that needed for the average day. If labour is flexible and arranged on a daily or weekly basis, then this may be a fair assumption. If more constant labour numbers are employed, then using an average feed rate may give an underestimate of the number of people needed. You can therefore change the figure in the adjacent box, multiplier for labour from average feed, to further adjust the number of workers required. For example, you might consider the labour needed for harvesting when selecting this value. There is a similar multiplier for the calculation of boat hours from the average feed. This data feeds into the suggested hours of fuel use per day value in the operating costs table. For instance, if the number of labourers for a certain average daily feed amount is 2, a multiplier of 2 would give a total of 4. If you are a farmer and know how many labourers you employ and how many hours of boat engine you use, you can just enter those numbers in the operating costs table, your values column. Using a ratio between feed quantity, labour and boat hours will be more useful for consultants, extension workers and students who wish to explore a wider range of production scenarios. The remaining costs in this table need to be specified directly, starting with the average labour cost per person per day. The next three cost categories in the operating costs table are expressed in terms of cost per kilogram of fish produced. If you have accounts from previous years and can identify your expenditure in these categories, divide that number by the number of kilograms of fish that you harvested in the same period to find the cost per kilogram. The other variable cost category includes any expenses that change in proportion to the quantity of fish produced. This may include expenditure on treatment chemicals, feed delivery charges, hire of equipment for harvesting, etc. As the purpose of this spreadsheet is to explore options for cage production, processing costs are not considered in any detail. However, you can include a figure in the operating costs table to represent these costs. Likewise, the cost of distributing fish to markets is likely to be highly variable depending on the farm, so a specific calculated figure can be included as a cost per kilogram. The next cost categories are again very farm specific. Firstly, if there is an annual site lease or license fee to be paid, include that under annual lease cost per cage. Divide the total cost by the number of cages that you operate, unless the fee is already on a per cage basis. If you have any shore-based facilities, such as feed and equipment store, staff facilities and office, etc., it is assumed that these are rented, and you should enter the annual rental cost in the field annual rent shore-based facilities. If they are owned by you, it is suggested that you calculate an annual cost for these facilities and enter that as an annual rent figure. Note this rent should only relate to land-based facilities connected with production activities and not processing, as there is a separate field later on for including rental for that building. The next three items relate to the need to access credit to purchase feed and fry. This may be in the form of an overdraft or other credit arrangement. Firstly, you are asked to enter the % credit days required for fry. If you need to borrow the full cost of the fry at the start of the rearing period and will not repay that until the end of the rearing period, enter 100%. If you do not need to access credit and can purchase fry from existing farm funds, you can enter 0%. If you only need credit to cover half of the cost, then enter 50%, etc. There is a similar line for feed. In this case, you are unlikely to purchase all the feed that is needed at the start of the rearing period, and due to the feed requirements generally increasing during the rearing period, the greater expenditure will be towards the end of the rearing period. As the interest payments depend on both the amount borrowed and the duration of the loan, even if you require credit to cover all of the feed purchased, the shorter duration of the later feed purchases will reduce the % credit day figure. As it is likely that feed will be delivered before it is paid for, some of the culture period may also be free of interest charges. On the other hand, if you are not paid immediately for fish when it is sold, you cannot pay back a loan at the point of harvesting the fish. This model is therefore not sophisticated enough to take account of all these variables. If you have access to previous data for a single batch of fish, look at the date of each feed purchase and calculate the interest payable based on the following formula. I equals OD times P times R over D, where I equals interest payable, OD equals the amount borrowed or overdrawn, P equals the days until repayment, R equals annual interest rate, and D is the days in a year, e.g. 365. Then sum the interest payable for each batch of feed purchased for the specific batch of fish. This is the total interest cost for the feed purchase. Now do the same calculation, but assuming all the feed is purchased at the start of the rearing period, requiring a loan for the full amount. Use the total rearing period as the days until repayment. Now divide the actual interest cost by the amount you calculated as required if you purchased all the feed at the start, and multiply that by 100 to give a percentage. Enter that value into the % credit days required for feed field. The default value is 40%. Alternatively, with the scenario set up to match your production, adjust this figure in the model until the charge for short-term interest payments matches your data. The next field is the interest rate for short-term borrowing, which is used in the above calculation, i.e. annual interest rate charged for overdrafts. The default value is 14%, but this is very variable, so should be checked and your value used where appropriate. Note you can only include an allowance for short-term credit to cover fry and feed, which are the two largest costs. It is assumed there will be sufficient finances available to cover other working capital requirements, such as labour and fuel. The last two items relate to whether you take a loan to finance your startup costs. If so, specify the interest rate per year that has to be paid and the percentage of the setup costs that are funded through a loan. Again, this is a considerable simplification. It enables you to see the impact of using loan financing in the early years of production. It does not account for the repayment of loan capital or the period of the loan. For the longer-term picture, simply set the percentage of startup costs to 0. The loans referred to here are long-term loans for capital equipment. If you wish to change the default values, scroll beyond the right-hand edge of the page and there is a separate table where you can adjust the default values. Once the table has been completed, the section below shows the calculated direct and fixed costs based on the overall strategy selected in the 5- comparison sheet. Firstly, the variable costs are shown. These are the costs that depend directly on how many fish are stocked and fed. The major costs are fry, fingerlings and feed. The annual costs of processing and distribution are also shown based on the information entered into the table above, and the cost of short-term borrowing for fry and feed. The direct variable costs are shown as percentage of variable production costs and as a percentage of total production costs. The next section summarises the annual fixed costs. These are the operating costs that do not depend on the number of fish stocked. Figures for maintenance and lease are included based on the values entered in the setup cost sheet and operating costs table respectively. There are then boxes for you to enter your cost information for additional items relating to post-harvest operations, such as building rent and standing power charges. Note that the model does not include any setup costs for processing, so if there is any depreciation, it will need to be included under the other fixed processing costs. Finally, in this section, you can add annual overhead costs, which are simply divided between marketing and administration. You will need to enter relevant values here for your farm for the full financial analysis on the 5- comparison sheet to be accurate. The next section simply summarises the totals as they may be presented in a typical profit and loss account. Finally, on this sheet, there is an analysis of the cost of tilapia production per kilogram for the chosen strategy, which is useful to compare with average sales prices. The first part shows the cost per kilogram for just the production operation, and the second part includes both production and processing and distribution. With all these costs set up, the financial analysis shown in the 5- comparison sheet should be more useful to you.